Welcome to the statistics lesson for week 4. In this lesson, we're going to go over probability and z-scores by looking at hospital data from children with various kinds of ailments, including infectious fever. Hospital records of the time show that many children were admitted with measles and other infectious fevers. I became interested in this by reading that Ada Lovelace was admitted to the hospital and was diagnosed with measles and was even paralyzed by it, and I wondered how common that was for children at the time. When I investigated, I found that there were not enough records of measles to make a very good project, so I enlarged my scope a little bit to infectious fevers, which measles is one of. Other examples include scarlet fever, typhoid, whooping cough, that sort of thing. And this could be relevant because the probability of a given type of diagnosis could affect how a hospital is administered. It might be important to have smaller wards because infectious fevers, of course, are infectious, unlike broken bones or nutritional problems, that sort of thing. Or it might affect the kinds of medicines that need to be ordered based on how many patients the hospital expected to have based on probability. So, my research question becomes, what is the probability that a child admitted to the hospital in 1861 was diagnosed with infectious fever? What we're going to do is count the number of patients admitted to the separate children's hospitals that have contributed records to our database from 1861, build a list of the different disease groups for patient diagnosis, count the number of patients diagnosed in each disease group, and then find the proportion of the whole for each disease group. And as we'll see, that gives us the overall probability for that disease group as well. So, let's take a look at the data. In this spreadsheet, I've imported data from all of the hospitals that we have access to. I don't need all of these data columns. For what I'm doing, something else that I've done is, out of the original data, where we have standard disease, and this can contain more than one entry, and we also have disease group, and this can contain more than one entry, I've done a little bit of processing on this data and put disease 1 and disease 2 in separate columns where appropriate, and disease group 1 and disease group 2 as well. For the purposes of developing a list, disease group 1 will be fine. I'm reasonably confident that there isn't anything in disease group 2 that won't also appear in disease group 1. So I'm going to go ahead and select this column, and as I've done in previous projects, I'm going to use the advanced filter command under the Data tab. And the advanced filter command lets me select a particular range. I'm going to copy that data to another location, and I want to take unique records only, and this is what's going to extract only one record for each. So I will only have one row that says tubercular disease, even though it appears multiple times in the record. And then I will copy that to a location that I choose over here, and just the first cell is sufficient. It will fill out the rest of the column for me. Click OK. Now this is my list of unique disease groups. I can use a number of interesting functions to work with this data. What I'll do is copy this and go to a new sheet to work with this, because it'll just be a little easier than trying to work on the same sheet. So here's where I've pasted the list of unique disease groups. And I have a couple of different functions here that will help me to analyze this data. Now, there are specific statistics packages that will do a lot of this for you, but you can do it in Excel as well. And these are some of the ways to do it. The COUNTIF function lets you count everything in a particular range that matches a particular criteria. So here, the particular range goes back to the data worksheet, column Y, and the criteria are located in the same row but in column A on this spreadsheet. So let's just pop over to the data sheet again and take a look. Column Y is the entire disease group. So this is a matter of very, very simple infectious disease analysis. I fill in the formula once, drag it down, and because of the way Excel works, for each row it's copying and saying, okay, here I'm going to refer to A17. Here I'm referring to A9. These are relative references and they always look in the column next door but the same row. So this gives me an accurate count for each of these terms from this column in my other database. Having done this, I can then sum all of these numbers, add them up, and I can do that very easily with the sum function and then select the range, and you can see that I've got all of my numbers included here. And then I want to use this to calculate the proportion and therefore the probability. So here's my probability calculation. I'm going to take the value immediately to the left from the B column and divide it by the sum from the bottom. So here you can see B4 will always just refer to the immediate left. Since I'm going to copy this down, I don't want it to start looking further down here for the division value, so this is where I put the dollar signs in, and this makes this a fixed reference, not a relative reference. It's always going to go exactly to this cell. So simple division, and I end up with my probability value here, and by copying that down. Now, as you can see, the row with the largest number of entries is, in fact, infectious fever. And something that can be very useful to do at this point is to select the range of data, not the whole sheet, but just this range, including the labels, and do a sort. So under Data, and choose Sort, and it's going to ask me, does my data have headers? And it does, so I want to say Sort By, and I want to sort by the count. I could sort by the probability because that's based on the same proportion, but just to simplify things, sort by the count. And I'm going to sort on the values, not on something to do with color or what have you. I'm going to sort largest to smallest. That'll give me the most significant disease group at the top and the least significant group at the bottom. Click OK. All right, now it has kept, because I've selected all of this range together, it's kept infectious fever with the data that belongs with it. I can see it. That's the top diagnosis category, followed by tubercular disease, and then joints, bones, and muscles. That would include things like broken bones. So something else that I can do at this point is make a chart. Go to Insert, and I'm going to make a column chart here. And this is because I've sorted my data before making the chart. My data are nicely sorted in my chart, and I can really see how steeply this curve drops. And these are just very unlikely problems compared to the ones up here, and you can really see that if infectious fever is just runaway lead compared to the other kinds of reasons that somebody might be admitted to a hospital. So I'm going to just move that down a little bit so that it's not blocking my information. Now, something else that we sometimes wonder is this data independent of another variable? And in this case, I'm curious to know, is any of this data tied specifically to the gender of the patient? In other words, are there more girls or boys that have infectious fever? Does it matter if you're male or female for any of these diagnoses? And to calculate that, I'll take this block of data. In fact, I can take the sum because I'm going to need that as well. and copy and paste that to a new worksheet. And here we see I've got the disease group, I've got the count, and now I have a new formula, and this is a subtle variation on count if. It's called count if S, and this lets me combine more than one condition. So previously I went and counted everything in the data worksheet and the Y column. Here I'm specifying a particular range in the data worksheet, and I'm saying I want to count the things that equal the value in A4. That's, again, 2 columns to the left. And I have a second criteria. I want to count everything in column D that equals F, where F indicates that we have a female patient. So here's column D, F equals female, M equals male. So what I'm looking for here is gender, indicated here just by female, yes or no, the number of female patients, is that independent from the particular disease? And again, there are more sophisticated methods that we can use to do this kind of analysis, but this is a fairly simple method, other than remembering how to do this formula, that you can do straight in Excel. So here, again, I use count if S, got this extra letter in the end. I look at the Y column and the D column, and if something matches my criteria in both of those, then they land in this column. So this is a female patient with tubercular disease, a female patient with growth and nutrition and decay, and so forth. Then what I want to do is calculate the proportion, or the percentage, of patients who are diagnosed with tubercular disease, in this case, who are female. And this is a very simple calculation. This is just the number of females divided by the number of patients with this particular disease. So you can think of this as how many females out of all of the patients with tubercular diseases. And in this case, 43.7%. Now, similarly, we've got our sum. We've got the sum of all of our female patients. This is fairly easy. We could have done this by summing off of the other page as well. We've got our percentages, but with our sum and our number of female patients, this gives us the proportion, or the likelihood, that a patient is female. So there's a 46.3% chance that a child admitted to the hospital that we have the records from is female. A little bit lower than 50%. That's not too unusual when we have such a large data set. There could be some reason for this, but we're not going to worry about that for right now. What we are going to do is compare this to the value that we got just on infectious fever. So we're comparing 45.2%, 46.3%. These numbers are not very different. I would say, in general, that we can say that the chance of a female patient and the chance of having infectious fever as two variables are pretty independent. These are not related to one another. And in cases of ailments of the nervous system, whatever that meant in the day, the odds are also quite low. And this is quite a bit lower than the 46.3%. So fewer girls were admitted with this kind of problem. Circulatory system, far more than the usual number of patients who were admitted with circulatory system problems were female, 65% compared to 46%. So this is how we can test for independence of these two variables. So that's where I'm going to end it as far as categorical variables go. I'll have another video that will show you how to make probability calculations for quantitative variables, which is a slightly different procedure. See you there.